All right, number 4 also says use substitution. With this one, I'm going to take a little bit of time to explain when substitution is easier, but I want to show you also how to use the calculator. So I'm going to show you how to solve these using the calculator as well. Hopefully it works out nicely for us and gives us some whole numbers. So number 4, when you do substitution, it's better to do substitution when x or y is already isolated. Meaning, so if I take this first equation, negative 3x, x is not by itself because it has a number in front of it. Minus 6y, y is not by itself because it has a number in front of it, equals negative 3. So in order to do substitution, you have to solve for either x or y. I'm going to solve for y. That just makes more sense. Normally we have equations in slope-intercept form, and we have y on the left and everything else on the right. So I'm going to solve this equation in terms of y equal. And this is what you would have to do to solve an equation by substitution. You got to solve for one of the variables first. So I'm going to add 3x to both sides. Bring down negative 6y equals, and then I have a positive 3x over there now, and I still have a minus 3. And then to get y by itself, I'm going to divide everything by negative 6. Or I could just say divide both sides by negative 6. I'll just put 1. It's basically dividing each of them, but just to be shorthand, I'm just going to do both sides like that. This will go away, so we will have y equals, and I can just leave it like this because I'm going to put it in the calculator, 3x minus 3 divided by negative 6. Or if you wanted to simplify it, this is the same thing as saying y equals 3x divided by negative 6, which we can reduce, and then negative 3 divided by negative 6, which also will reduce. As a final answer, I'm doing the arrowhead. This would be y equal 3 divided by 6 is a half. It would be negative, so a negative 1 over 2. And then negative divided by negative is a positive. This should be 1 over 2x. And this would just be a positive 1 over 2. So I solved this for y. And then I would do the same thing with the other one and plug it in. But I'm going to do this and plug it in the calculator. I want you to see the calculator method for graphing anyway. So that was equation number 1. I'm going to take equation number 2 and do the same thing. 9x plus 18y equals 8. And I'm going to solve for y. So subtract 9x. I will go away, bring down the 18y equals a negative 9x plus 8. We're going to divide by 18. So I'm going to go ahead and put everything and simplify it. 18 divided by 18 is 1, so that leaves me with y equals 9 over 18 will reduce to 1/2, so a negative 1/2 x, and 8 over 18, both of those are divisible by 2, so that would leave this with a 4 over 9. Okay, here is one nice thing about graphing. Okay, if you are, and I hope you all are, very familiar with slope-intercept form, you notice when you look at these two equations that they have the same slope. Okay, when you have two equations with the same slope, that means they will be parallel. So I know immediately, without doing anything, once I put them in y equal format, these two lines are parallel, they will not cross, I will get no solution. Okay, so let's confirm that with the calculator. So I have my little on-screen calculator. Turn it on. Go to y equal. Clear out what we have, and I'm going to type these equations in. So it already has the y over there. All I have to do is type in the right side. So I'm going to do negative 1x divided by 2. So that's 1/2 x plus 1/2. Okay, so that's equation number 1. Enter, go to the next line. Equation number 2, negative 1x divided by 2. So same slope. And then the intercept this time is going to be plus 4 divided by 9. All right, I'm going to hit graph. There's one line. And the other line is very, very close. You can't even see it. So let me zoom in. Let's say zoom, maybe say decimal. Did I miss decimal? Where's zoom decimal at? I got it. Oh, there we go, number 4. A little bit closer. It still looks like they're almost right on top of each other. Let me zoom in a little bit more. 2. Should be a small gap. My little cursor is right there. I need to go up because I want to zoom in on this spot right here. Hit enter. Zoom in a lot more. Okay, there we go. You got to zoom in really, really close to see the gap if you're going to graph it. But you can see the small gap once you zoom way, way in because they're so close to each other. It's hard to see them apart. The distance between 1/2 and 4/9, really, really small. So you can see that these two lines do not cross. They don't intersect. They're parallel. So we're going to get no solution. So I'm going to say the system is inconsistent. We do not get a solution.